Yeah.
Okay, thank you, John. You'll be watching the Q&A then. Thank you very much. So I'm going to start the presentation. We have 4 topics today for this session. I'm going to speak about the future of data and how can we increase the value of the data we have in our Oracle databases. I'm going to speak about REST APIs. We have simple Oracle document access APIs, which are different APIs from the REST APIs. And also I'm going to speak about how to include all these new concepts in a continuous delivery, continuous deployment workflow with continuous integration, continuous deployment using Oracle database. So I'm going to start with the future and about data. So we say that the future is data-driven. It means that the data is becoming more and more important for any business that will start today and more important in the future. We have seen that many businesses, they don't own any assets. They have just data they use to run and to make money. So that's why we say that the future is data-driven. We have to get the value from the data we have, or we will receive, we will have at a certain point in time. And the data is, of course, we are Oracle, we're going to store data in Oracle database. And we will use the features of the Oracle database to increase the value of the data and to run businesses just with data and nothing more. What kind of features can we use within Oracle database? Because this is an advantage we have. We don't have to write code and create new applications for improving the value of the data we currently have or we will have in the future. Everything is already included in the database itself. We have machine learning features, we have analytics features, Internet of Things, social analysis with graph database, graph data structures, documents data in JSON format, XML format, and could be plain text format, spatial data. And now, for example, for the last few years, we have seen blockchain, a new kind of data which is appearing in the market and is going to be used more and more in many applications, starting with the cryptocurrencies, voting systems, and many more applications that will use the blockchain data in the database to increase the value and to improve the business we have or we would like to have using this kind of data. I'm going to give you some examples for each one of these new concepts and using the current technology we have inside Oracle database, how to improve the value. For example, with machine learning, it's very easy to use the data we have to create, to make predictions, to create a sentiment analysis or real-time recommendations for our customers, to detect fraud in our transactions, to improve basically everything at the business level, from the customer experience to the security of our business and to the success of our business. We have machine learning that can be used directly inside the database, and we can use directly SQL or PL SQL with data mining from inside the database, or we can use programming languages like Python and R with very powerful algorithms to improve run machine learning predictions and algorithms in using our data, our own data. And if until today it was a little bit more difficult, or let's say it required a little bit of experience when we needed to run machine learning on top of the data we had in Oracle database, with the latest generation of the database with Oracle Database 21 we have AutoML, automatic machine learning, which will give you the full capability of machine learning with no restriction and with no experience regarding data mining and machine learning algorithms. The database will run the algorithm for you, will choose the best algorithm. It will improve the parameters on the algorithm configuration, and we will give you directly the predictions based on the data you have inside the database. And you know, another big detail we have here is this is completely free. So it was previously a priced option included in advanced analytics database option, but now it is included in all database editions, and it doesn't require any extra price. It is completely free. We have 20 years of experience with machine learning, so this is not a new technology for us, for Oracle. And we have tens or hundreds of algorithms available from within the database you can use to make predictions and to improve the customer satisfaction, for example. Here we have some of the categories for each kind of for the groups of algorithms we have in the database, like classification, text analysis, attribute importance, regression, linear regression, and so on. So I'm not going to go too much into the details, into the technical details. I'm going to give you just an overview. And if you want to have more details on or how to do it, you can get in touch with me, and I can give you the information you need to get started with this technologies, with these features I'm going to present today in this session. The next feature is real-time analytics, and we are using in-memory features in Oracle database to improve the performance on analytics. We can run analytics hundreds of times faster than other databases, because we have two formats available at the same time for the same tables, the column format and the row format. For example, you can have the same table with just some columns into the memory in columnar format, and the rest of the table with the important rows, which are mostly required by the application, in row format. And once you run the query on the column format to find the exact columns you are looking to get the information from, you will get the rest of the record, the rest of the row from the row format. And this improves the application performance hundreds of times. So you can use it directly on OLTP databases or even on data warehousing, because if you have a data warehouse, today the amount of memory available on Oracle servers, it's very high. The memory is cheap, and you can have a complete data warehouse into the memory, because data warehouse is like 50 terabytes in size. They can fill into the one server memory size completely, and it's very easy to use. You can receive data from devices. We have the new concept of Internet of Things, and those devices generate large amounts of information in a very short amount of time. And now we have this new feature, which is the fast ingest, is called, that can be used to insert huge amount of information in the database in a very short amount of time. We have experienced 25 million inserts per second with just a 2-socket server. And this data can be used for the real-time analytics I described in the previous slide. So it's very easy to use. You just need to create a table basically with this feature enabled, and then you connect the devices to your database and you insert the data. The data will bypass the transaction engine of the Oracle database, and it will get to the Oracle database storage to the fastest way possible. So it's very fast and very easy to use. We have graph analytics using Oracle Graph, which is also completely free now, included with all database editions. We have over 50 graph functions available with the Oracle database, and they also leverage the in-memory features of Oracle database. And we have specific query language, which is named Property Graph Query Language, PGQL, that can help you to use graph in your ordinary applications and to make it available for your customers, for your end users, for your applications immediately out of the box. Here are some examples of the graph analytic functions we have inside our Oracle database, and this is also very easy to use. It's already available and provided by the Oracle database. You don't have to code this into your application. You don't have to create new modules for your application to leverage graph analytics on top of the data you have in Oracle database. We have document support. We have native JSON support and XML document support inside the Oracle database. And it allows you to query information you have in these documents from the Oracle database itself. And you can use just simple SQL functions or SQL language or PL SQL. But we also have simple Oracle document access SODA APIs you can use if you don't have any SQL experience or PL SQL experience. I'm going to give you some more details about JSON in one of the next sections of this presentation. And that's when I'm going to explain how SODA API works exactly. Then we have spatial. Spatial data is everywhere today. With spatial information collected on mobile devices or even on laptops, for example. Today I have seen all laptops, they have location services enabled, and you can get more information from the data from people, from the end users, from applications you run on mobile devices or on your laptop. You can use that data to analyze, to improve the value of the application and to get more value out of the data. We have hundreds of spatial operators and functions available in Oracle database, and like Oracle Graph and like Oracle Advanced Analytics today, Oracle Spatial is also free, and it is included with all Oracle database editions. You don't have to pay any more extra fees for the Oracle Spatial option in order to use it. And here is a list with hundreds of spatial functions and procedures available within Oracle database that you can use to improve the predictions, to improve the customer satisfaction, to get more value out of the data you currently own and you have in your applications, in your databases. And blockchain. Blockchain has been made very easy to use today. So we use blockchain just to prevent fraud and to validate, for example, certain records inside the database. It's very easy to create a blockchain table in Oracle database. It has been started with Oracle 20C in the preview mode we had on Oracle Cloud. It wasn't available on-premise, Oracle 20C. I've seen some people asking about Oracle 20C. And now we have Oracle 21C. Oracle 21C, it's also available currently in the cloud. We don't have exact dates for the on-premise or other platforms available, but it's available on Oracle Cloud, and you can create blockchain tables. And in a table, in a blockchain table, basically the rows are cryptographically chained, and you cannot change the rows, you cannot delete rows, you cannot modify the rows, you cannot alter the data which is already inside a blockchain table. And you can verify the information that has been introduced, inserted in a blockchain table. It's a very easy to use process to validate the records you have in a blockchain table. And this can be used in many use cases. And it is also available by default with the Oracle database. and it can be leveraged using declarative SQL or PL SQL. So you don't have to write customized code in your applications in order to use the blockchain technology in your projects. And we have also new development paradigms available, so you can include these new features into your current projects or in your future projects. For example, Oracle Database will help you to develop microservices and to migrate from monolithic applications to modular applications using microservices, using the new cloud technologies and containers and Kubernetes and all the technologies around microservices. Again, I'm not going to go into the technical details because, yes, I'm technical and I usually can go into more technical details, but I'm trying to stay here just at the overview presentation at a very high level. You can use it in streaming applications using events like Kafka, Java messages, and so on. So there are paradigms available to be used directly with Oracle Database, and Oracle Database supports this new development trends, these new development standards and designs using messages. You can use the Oracle Database in software as a service deployments for your applications. We have also, apart from the public cloud we provide to our customers, we have private cloud configurations with schema as a service, pluggable database as a service, and database as a service you can deploy on your own data center. And this is also one of the new standards we support from Oracle Database. We have distributed data with sharded databases. These are globally available databases in high availability configurations using a new technology, which is the sharding technology. And I'm going to have some details about it. We have the new continuous delivery technologies and paradigms using Oracle Database with CI/CD pipelines and workflows. We have API-driven development, defense in depth and low-code application development with Application Express and REST data services. And let's go a little bit to see about each one of these paradigms, or some of them, what they offer and what we can use to improve the experience on the development on our projects. First of all, we have the pluggable databases. Pluggable databases are the databases we use to provide isolation and individual containers to store the data for microservices architectures, for example. It's very easy to use, and pluggable databases are available in Oracle Database since Oracle 12c database. And now we have improved and enhanced the features we make available with pluggable databases for this new way of development, new standard of development. We also have the data as a microservice deployment model. For example, you can install or you can provision a database in the cloud directly with the microservice, and you can communicate with the database using REST APIs, using Oracle REST Data Services, ORDS. You can use REST with programming languages or on top of the SQL and the PL SQL stored procedures. So this is a new way of extending the microservice capabilities with the features and the functions we have directly in Oracle Database that can give you access to the data and then they can serve basically as a microservice in itself. And then we have the software as a service architectures. So we have the software as a service architectures you can deploy on the public cloud using the services, the database services we have available there, like the autonomous database, like the database the cloud service and the Exadata cloud service. But you can also develop and create your own software as a service deployments using the private cloud configurations. So we make it very easy because we also leverage the multi-tenant architecture, and you can consolidate at the pluggable database level. If before pluggable databases, we used to consolidate our applications at the schema level. Now this is not anymore a best practice. Now we use the pluggable database as the best practice to consolidate your applications on a very single environment, on a single server, and to isolate basically your environments, your platforms in different tenants, in different pluggable databases, which are completely separated one from another at the security level and also at the performance level. They do not compete for the resources, because the resource manager can be used to separate resources and the performance between all the pluggable databases running on the same server, on the same machine. And we also provide support for the continuous delivery paradigm, leveraging the CI/CD, continuous integration, continuous delivery pipelines and workflows. And you can use Oracle database in such pipelines and workflows. I'm going to give you more details about in the last section of the session. And I want just to mention here that we have more features in the database which will allow you to implement CI/CD on top of Oracle database, like edition-based redefinition, which allows you to create multiple editions of the application schema, of the structure of the data you have for your application at the same time in the same database, and to run multiple versions of your application on top of the same database at the same time. Online table redefinition, which allows you to modify the structure of a table in real time and without having to take the table offline in order to change the structure of the table. And then we have the schemaless development on top of JSON and XML document stores. We're using Oracle database, the same Oracle database. And being schemaless, it doesn't have a fixed structure. So you can change the structure of the data at any time you wish, even from one day to the next one. So there are many features available inside the Oracle database which allow you to implement continuous integration, continuous delivery with Oracle database. It's very easy to implement. Distributed data architectures are made possible with the Oracle Sharding. Oracle Sharding is a way of transforming monolith database, individual huge database, into smaller databases which are completely independent one from another, but they work and they function as one single database. So you can place, for example, different shards. The smaller databases, we call them shards. You can place these shards in different countries, in different locations, for example, for regulation purposes, for company policies, or just to be closer to the end user, because the performance is going to be improved and the user satisfaction is going to be improved for your database. Shards are fully isolated and they work as individual databases actually. So they are actually individual databases. They are database installations with everything they need to run. And the availability of the big database, it does not depend on the availability of single shards, smaller databases. So you can take one of the shards down at any time and the application will still continue to run. Of course, using sharding, using Oracle sharding, you need to have applications that are specifically designed for sharded databases. So not all applications will run on sharded databases out of the box without any modifications and completely transparent. You need to have applications specifically designed and architectured, configured to run on sharded architectures. And then we have the Application Express and low-code application creation with Apex and Oracle REST Data Services. Apex is a very important feature of the Oracle database, and we have seen more and more companies adopting Oracle Application Express to create very simple and very productive applications on top of the data they already have in the database. You can integrate Apex with other features like location features, like JSON documents, like a document store, object storage services in the cloud, and many other services available in the cloud. And you can create an application in a matter of minutes, actually, a very basic application. But I have seen big applications with many features, with many functionalities created using Application Express, and they are very, very productive. Let's say it's very easy to increase the value of the data using Application Express. And let's talk a little bit more about REST APIs and about using the native JSON support. So what is Oracle REST Data Services? I was mentioning before, because this comes with the Oracle Application Express by default. So whenever you create an Application Express workspace in your database to create a very simple application using a spreadsheet, for example, you immediately have REST Data Services, and you can enable REST Data Services for your data in your database. And you have a graphical user interface to control it and to see the methods and the endpoints you provide on top of the data. So Oracle Data Services is a way to receive and send information from your database or to your database using a very simple REST client. What's a REST client? It can be your browser. Your browser on your laptop can be used as a REST client, because you can receive data from an Oracle database using Oracle REST Data Services just by typing the URI, the URL from the database you get from when you enable Oracle REST Data Services into the browser search bar, and it will retrieve the information from the database in JSON format. It will get the information from your Oracle database in a JSON structure. What kind of sources does Oracle REST Data Services use to retrieve information or to store information to? You can use the Oracle Relational Database, any kind of Oracle database you may have installed in your data center or on the cloud. It can use document store, an Oracle document store, an Oracle database that has been configured specifically to store documents like XML and JSON information. We have, for example, now an Oracle JSON database, an autonomous JSON database available in the cloud, in Oracle Cloud Infrastructure. Or it can use a NoSQL database, Oracle NoSQL, that can be used as a source of information for Oracle REST Data Services. So if you just have an Oracle database you have installed on your own server, you can use REST Data Services to map an URI request you will type in your browser to the corresponding relational data in your database. It can be relational data, or it can be non-relational data, unstructured data. And then By default, the Oracle REST data services will transform the data into JSON format, but you can use multiple formats like HTML, binary, or CSV, comma-separated values like text, flat text files. And let's see how it works. Let's say you want to receive the information about one of your customers, and you have enabled the customer's table from your database with REST data services. So you just need to type the correct URL in your browser, and the service, the Oracle REST data services, will transform this URL into a SQL statement. For example, select from customers orders, in this case from orders, where customer ID equals 1001. So this transformation is performed by the Oracle REST data services. And then the data is served to the Oracle REST data services, which will by default transform this information into a JSON output, which will be displayed in your browser, in your on your laptop. So this is the way it works. It's very simple to use and very easy to enable on your data. As I was saying, Application Express has a graphical user interface which can be used to create endpoints and to enable REST services for your existing columns and for your existing tables inside your Oracle database. What can you use it for? You can use it even for management. For the Oracle database management, you can use REST APIs. And I'm going to give you some details right now. So we have different REST endpoints that have been created with the Oracle REST data services installation and enablement on top of an Oracle database that can be used to manage the database. We have endpoints for generating information about the database, the status, the availability, about the data dictionary, about monitoring information and performance metrics, and also about pluggable databases, lifecycle and management of pluggable databases inside a multi-tenant architecture container database. So the first step would be to go to the documentation, for example, to the REST APIs for Oracle database documentation, and to get the endpoints you need based on the exact use case you wanna implement with the REST data services on top of your database. So you can manage and monitor any kind of Oracle database using REST APIs and REST calls. And this is available since, it has been made available using Oracle REST data services, starting with Oracle Database 11G Release 2 and higher versions. It also can be used with user authentication. So if you want to make it secure, the REST calls you want to perform on top of your data or your database to manage your database, you can use the OAuth capabilities of the database itself to enable it for a certain client and to use some authentication to get a token, and then with the token you can use the token to run REST calls on your REST enabled data. So it's completely secure. It uses the HTTPS with the SSL encryption, and it is fully secured by the Oracle REST data services itself. You don't have to do anything about it. You don't have to install anything on top of it. So the very single steps you have to perform in order to enable it and to make it work for your database is just to install the wards. We advise you to use the latest version of Oracle REST data services of wards, and then enable it. We have a configuration XML document on which you have to make some changes in order to enable REST data services for your database. And in case you want to have some examples or to have a very simple overview about the capabilities available with the REST API, you can use the Swagger JSON document, which will give you an overview about the capabilities and the features available from Oracle REST data services. So here we have two options in order to start using the REST data services. We have the documentation, where you have the complete list of the REST endpoints, and they are grouped by the use case. For example, for data dictionary, for monitoring, and management performance metrics, for example, from the database, we have different endpoints. And the other way is to use the Swagger JSON document and to get a very quick overview of the capabilities you can and the endpoints you can use and the methods available for each one of the endpoints you can use to monitor or to extract data from your database using REST calls, API calls. I'm going to give you a very simple example about management use cases on top of an Oracle database using REST calls. In this case, I'm going to list the invalid objects inside the Oracle database. So I'm going to go to the documentation. I'm going to choose the documentation way of starting my project. And I'm going to find the endpoint for the database objects in the data dictionary tasks. So I'm going to get this endpoint, and I'm going to try this endpoint on my data. If you run this a REST call, a GET REST call on top of your database to receive the objects in your database, this is the equivalent of select all from DBA objects. You can run the same statement in SQL Developer and see exactly what you're going to receive in the JSON document in your browser. But in this case, I don't want to get all the objects because I want to get only the invalid objects. There are ways of specifying filtering on top of the URI, and we are using the query attribute here, and we have the different filtering options like equal, greater than, lower than. In this case, I'm going to use the equal comparison to compare the status to a fixed string. In this case, the string is going to be invalid. So if I run the same URI I got from the documentation from those objects, database objects, using the query, the parameters on the query, I run basically the equivalent of the select all from DBA objects where status is equals invalid, and I'm going to get just the invalid objects in my browser. I have a question on the chat here. Let me see if I can answer it. So do you see ORDS Management API as an alternative to Oracle Enterprise Manager? I wouldn't say it's an alternative because Oracle Enterprise Manager has a lot more features than just what we can get from Oracle REST APIs. But yes, it's a way to, you can do it using Oracle REST data services. So yes, you can do it if you want. But of course, if you want to build those nice looking charts you have in Oracle Enterprise Manager, or the top SQL, or you want to have access to the advisors, for example, you have to build it, most of it by yourself, because the Oracle REST data services won't build the charts for you, won't give you the wizards for the advisors, for the SQL Access Advisor, for the SQL Performance Analyzer, and everything you have in Oracle Enterprise Manager. So yes, it's a way to do it from a very basic level and very convenient because you're going to use just the API calls and you don't have to connect to the Enterprise Manager to perform the tasks. So how do I use the JSON information? So I'm going to receive some JSON information from the REST APIs, and I want to use it. I want to do something with it. I want to understand this JSON information. We have native support from Oracle Database to work with JSON documents, to process JSON information directly from within Oracle Database. Let me see if I have one more question. Okay, no, it was just one question. So let's see how we process JSON information from the database itself. We can use JSON information in any kind of transaction, like standard BML transactions. We can use APIs. We have multiple APIs available, and they are very similar to the NoSQL APIs, but in Oracle case, we call them SODA APIs, Simple Oracle Document Access APIs. And we have them available for Java, for Python, JavaScript. So most of the, let's say the most important programming languages. And then we have them also for C, for REST calls, for PL SQL. So you can use REST calls from the PL SQL itself. You can use analytics, and everything you have seen in the data-driven application development in my first section on top of JSON information. So JSON information can be used in analytics with columnar access, parallel queries, query by example, and so on. We have features which will allow you to use this information in a very easy manner, like a data guide, JSON update operations, and JSON functions. So now let's see a little bit how JSON has evolved in Oracle Database since it was first released with Oracle 12c Release 1 until now. Let's say we still speak about Oracle 19c because it's going to be the database. This is the long-term release we have currently with Oracle Database, and we strongly advise you to use Oracle 19c in your projects, in your current applications, for example. So on the left side of the slide, I have the same query in 12.1, and on the right side, I have exactly the same query in Oracle 19c, and you can see here that the JSON support has evolved, and it has been simplified. So now you can query JSON information very easily using the simple dot notation, and you don't have to specify the full path of the fields in the JSON documents like you were supposed to do in Oracle 12.1 database, in the first release of the JSON native support in Oracle, on top of Oracle Database. How would you understand the JSON document? How do you know exactly what kind of fields you can query from those documents in your database, because you don't know the fields, you don't know the structure of the documents? Well, it's very simple. You can use the data guide to understand the structure and the values and the fields inside your JSON documents. So you can use a data guide on top of the JSON documents, JSON collection, let's say you have in your database, which underneath has a table with a JSON column, but let's call it collection of documents. You can run a data guide on top of a collection, and it will retrieve all the information regarding the fields and the values, the ranges, the sizes, the data formats, and everything you have in that collection. And with that information, you can run your queries. Let's see how it works in practice. Well, I said I'm going to go too much into the technical details, but I just need to give you a very simple example. So once you run a JSON data guide on top of a table, a collection of documents, this is what you're going to receive. You're going to receive complete information about all the fields, their size, their data type, and their location inside the document collection. And you can use this information to run your queries, or you can use it to improve the performance on your queries. For example, you can create materialized views, or you can create virtual columns on top of the collection of your table. And you can run your queries to receive the information directly from the virtual columns instead of going through the document structure and receiving the information from those fields in your documents. It's very easy to use. And then we have multiple other features, more other functions that can be used with those fields in order to improve the experience using JSON documents on top of Oracle database, or to retrieve information faster, or to use filtering, or to create materialized views. For example, for the best performance of the analytics, of the analysis. We can, for example, check if we have empty or missing elements, for example, in JSON documents using JSON exists function. And we can update individual fields inside our documents using JSON merge patch function. This is a way to update individual fields in a document instead of retrieving the full document, processing the information to change the field, and then inserting the full document again into the database completely. So the performance is improved, but also the optimization of the JSON performance and the procedures when you're working with JSON is improved a lot. It's a lot faster to change just one single field than to reinsert the full document after processing. And if you don't want to use any kind of SQL or PL SQL, we have the simple Oracle Document Access, the SODA APIs. So there are two ways of communicating and using JSON inside Oracle database. To use JSON as a data format for communication, for example, in case of REST data services, you can use SODA APIs if you don't want to have any kind of SQL or PL SQL experience, or you can use SQL and PL SQL like I've shown you in the you have seen in the previous slides. Just excuse me for 1 second. Okay, so let's see how SODA API works. SODA API is a NoSQL style API, and it has been written for Java, JavaScript, Node.js in this case, Python, REST, C, and PL SQL. You can use SODA APIs to manage JSON data in collections inside your database in the same way you do with any other NoSQL databases APIs. You can use it from different tools or from those languages you have seen in the list, Java, JavaScript, Python, and so on. The tools we recommend to use, if you want to use it from a tool, it's SQL CL. It's SQL command line interface you can get from Oracle Technology Network, and you can use to run SODA API commands. And this is an example here on the SODA commands you can run from SQL CL, and this is actually the manual page, which is listing all the commands available and the options and the parameters you can use to run those commands. In case you want to use SODA from within a programming language, here are some examples. It's very easy to use. So instead of running code, PL SQL code, or customized code to retrieve the information from the database, you can use the API calls. And here I have an example from Node.js. You can get SODA. You can use the get SODA database to create the connection, and then just use the API call, the create collection function, to create a collection. So basically this code, it connects to the database, creates a collection, and then it drops the collection. It's very easy from any kind of programming language. And if you want to have a comparison with an existing NoSQL database API calls, we have here a comparison. This is Java, Java language, between MongoDB and Oracle SODA, Oracle Simple Oracle Document Access API. And you can see here the code it's very simple. On the left side we have MongoDB, on the right side we have SODA APIs, and you can see it's the very simple amount of code here with a very small amount of lines, and you can do the same from a NoSQL database with API, with its proper API, and from Oracle database. And this is the last section of the session today, the continuous integration, continuous delivery with Oracle database. So if you want to implement all these features and you don't want to bring down your application, and you want to implement these features little by little in very, very small steps without interrupting your end users activity and your applications, enterprise applications, you can use this approach to apply small changes and to develop your applications in very short cycles with continuous integration, continuous delivery. So you can integrate this development also with the database. You can use the changes on the database side in the same way and in the same pipelines and cycles as you apply the changes on the application side, on the application development. And there are two ways of capturing and applying changes on the database side. So if you use, for example, different tools to and CI/CD servers like Jenkins to identify the changes in your code and to create a versioning system in order to apply those changes to your application into the testing environment from development, you can use the same way and the same approach with Oracle database. We have two approaches here with Oracle database, the state-based and the migration-based. The state-based is extracted from a comparison between the two states of the database structure at two different times, and it will generate a change log based on the differences it finds between those states. And the migration-based, it's based on the experience you have, your development department has when they apply changes to the other environments, and they will use their experience to create and to generate a script with the changes, a change log that can be used to apply those changes on top of the testing environment or staging environment, whatever you have in the next stage of the development. How does it work? It uses Liquibase. Liquibase is a tool which is not developed by Oracle, it's a different company. And it's a tool that can be used to source control your database changes. So it's basically an open source project. They have the community edition, which can be used open source, but they also have an enterprise version of the tool that can be used for more important projects in mission critical applications. And it supports very well Oracle database and also other tools we have for Oracle database like SQL. So if I was promoting, let's say, SQL command line to be used with SODA API calls, I'm going to say the same here. I'm going to recommend you the same tool to be used with Liquibase, SQL to source control your database changes. And those changes are saved in change sets and change logs. And they can have multiple formats. They can have an XML format, a JSON format, YAML, or SQL. So those change sets will represent actually the changes in your database structures that you have to apply in order to integrate your changes into your staging environment, or to deploy or to deliver your changes from the staging to the production environment or testing environment, let's say. So in a continuous integration, continuous delivery approach, you will need Liquibase basically in all the steps, in all the pipelines and workflows in order to migrate changes from one stage to the next one. And how does it look like? Well, you have multiple change logs, and they are grouped in change sets. And then you have a controller, which is the master change log, which will specify the order in which those change logs have to be applied, and it will contain all those change logs you have for each one of the modules. And this is also available from within the database. We have a database changelog table. This is a physical table inside Oracle database, which is used by Liquibase when you deploy Liquibase on Oracle database to store the same information and to be used as a control to track and see exactly what changes have been executed and what stages are those changes at. So you can get very detailed information from the database changelog table, and you can use it in the same way as the change logs. And again, I'm gonna speak about multi-tenant architecture that can be used to create your branches. For example, you have a production branch and the master development branch, and from that branch, you will have to create multiple branches for your application modules and for each one of the developers you have in your development team. And when all the features are integrated back into the master development branch, you will have to create a release branch, which will be used by the QA engineers to test the release and see if it works properly. So in this case, we have multiple features that can be used with multi-tenant architecture, like cloning, hot cloning, snap cloning, refreshable clones, online pluggable database relocation. So we have multiple features with pluggable databases within Oracle multi-tenant architecture that can be used with your CI/CD pipelines and workflows at the database level. If you have seen that the changes can be monitored and controlled using Liquibase, everything else can be controlled and implemented using multi-tenant architecture and all the features we have in multi-tenant architecture. So there are recommendations we have for the CI/CD implementation on top of the Oracle database. You should cover all the code you have and all the changes with automated tests. You should use environments for development and testing as close as possible of the production environment of the production branch. So if you create branches from the production for your development departments, you should use maybe pluggable database hot cloning to create those environments in order to have this exactly same structure of the data in those environments as the one you have in production. And of course, if you are afraid of losing sensitive information and making it available to external teams, you can use data subsetting and masking to cover your sensitive information before you share those environments with the production from the production with the development departments. And you have to design proper testing strategies, because if you design the proper testing strategies and if you have the proper configuration and maintenance of the continuous integration, continuous delivery server and the source control system, you can use the rest of the time on problem solving and on innovation for the application instead of fixing bugs and making sure the code integrates back into the production when the features are completely developed by the development. So there are multiple benefits of using continuous integration, continuous delivery with Oracle database. You can eliminate basically the risks of integration of the new features into your production application. We have higher code, higher quality of the code. We have always a code which is always running on the version control server in this case. And of course, the time to go to market is going to be reduced. So this is the whole session. Our mission is to help people see data in new ways, discover insights, unlock endless possibilities. And this is what I was trying to show you in this session today, to see how to improve the insights and to get more value out of the data you currently have. I hope this presentation was helpful, and I'm going to ask you, I'm going to wait for more questions right now, but you can also get in touch with me at any time using my email. So you can drop me an email with your concerns, with your comments. And thank you very much for your patience, because I know it took a little bit longer than 1 hour, but I just wanted to share all this information. Thank you very much. If there are any questions.
Valentin, thank you. We wait a little bit for the questions.
Yeah.
But I already want to thank you for your insight. And it's almost like you wanted to say Oracle made easy. I saw some slides coming over Spatial made easy, SaaS made easy, etc. Oracle made easy. It's nice.
Yes, it made it easy and also free.
Yes.
You have to remember, Spatial, graph, analytics, machine learning is now free.
And Liquibase is worth analyzing it, I think. There's a question. There's a question.
Yes.
Any possibility that JSON binary type introduced in 21C will get officially backported to Oracle 19C?
I don't know exactly, because in Oracle 19C we have 3 data types we can use to store JSON. We have varchar, glob, and blob. There are some small differences between this kind of each one of them. Let's say the fastest is the blob, but the easiest and more convenient is the varchar, let's say, because you have human readable format already and you can query it immediately. I'm not sure if we are going to backport the JSON data type to 19C. We'll see about that. We already have customers very happy with the varchar, blob, and glob, and they don't have any complaints about it. So for best performance, we recommend blob. For easiest way to do it, we recommend varchar.
Okay, thank you. Then I'd like to close this session. Yes, I want to thank all for listening. And I want to thank you again, Valentin, for your
Thank you very much, Job, for the support.
Thank you.
And we're looking forward for the next sessions on Netherlands Oracle User Group. Okay.
Thank you.
Have a nice evening.
Have a nice evening. Bye.
Bye.